We've now talked about measures of central tendency, the mean, median, and mode, ways to measure the center. And we've talked about variation, ways to determine how much something varies. Now we're going to look at measures of position. If I have a particular data point or a set of data points, how do I know where they are in relation to the rest of the set? And the first way we're going to do that is with Chebyshev's theorem. Chebyshev's theorem tells us how much of the data lies within a range of numbers. In particular, it looks at the proportion of our data that must lie within k standard deviations on either side of the mean. So we know what our mean is, and we know what our standard deviation is, and we want to know how much is within 2 standard deviations of the mean, or 3, or maybe 1.5. And the answer is it's at least 1 over 1 minus 1 over k squared. And this is an at least thing. So we don't really know exactly how much, but we do have a bound. We know so much of it must lie within this amount. So let's do some examples and exactly see what that tells us. Let's suppose we have our mean and we want to know how much data is within 2 standard deviations. Chebyshev's theorem says we now have 1 minus 1 over 2 squared, which is 1 minus 1/4, which is going to be 0.75 or 75%. So at least 75% of our data is within 2 standard deviations from the mean. It could be more than that, and it could be, but it cannot be smaller. We know it has to be 75% or more. If we want to look at 3 standard deviations, I now have 1 minus 1 over 3 squared. So 1 minus 1/9, which is going to be 0.889 or 88.9%. Once again, it could be more than that that's within 3 standard deviations, but it is at least that. And now that we've looked at that, let's look at some actual numbers and see if we can figure out how to use this theorem. In this case, we have something that we know the mean is 50 and standard deviation is 4, and we want to know what percentage is between 42 and 58. So first, we have to see how far 50 is from each of these numbers. Between 50 and 42, the distance is 8. And between 58 and 50, the distance is 8. And these numbers should match every time. So now that we know exactly how many data points are away from the mean we're looking at, we need to know how many standard deviations. We know that S, our standard deviation, is 4. And we know that 8 is 2 times 4. So 2 standard deviations. So that's our K number. And if we work that out, we get 75%. And it's not exactly 75% of the data, but at least 75% of our data is going to be between 42 and 58. In another example, we still know the mean is 50 and standard deviation is 4, but this time we want to know what range accounts for 88.9% of the data. So in our last example, we had the range, and this time we have the percentage. So we don't know this K number, but we know that 1 minus 1 over k squared needs to equal 0.889. And we could solve this, but we don't really want to do that. Instead, we're going to think back and remember that 3 standard deviations accounted for 88.9% of the data, which I showed you shortly after I defined Chebyshev's theorem. So we know 3 standard deviations. So we need to go 3 times our standard deviations below the mean, and also 3 times our standard deviations above the mean. We know that 3 times 4 is 12, so 50 minus 12 is 38, and 50 plus 12 is 62. So now we've said that between 38 and 62 holds at least 88.9% of our data. The next thing we're going to look at is percentiles. Percentiles is another way to measure where a data value falls in the entire set. The pth percentile is a value such that p% of data falls at or below it. So what exactly does that mean? Suppose we have the 89th percentile. What this tells us is that 89% of the data is at or below this number. It also would tell us that 11% had to be at or above this number, since 89 and 11 makes a full 100. So this is what the percentiles mean. I won't go exactly into calculating them here, but it's important to realize exactly what they tell you. Percentiles are used quite often, especially with standardized testing, or if you go to the doctor, especially with children, you'll see their height and their weight percentile. It tells you how many people or what percentage of people are at or below where you are at.